Okay, today I'm going to show you how to work one of the problems on your homework checkups that I think gave several of you a little difficulty. You have all the tools already that you need to work this. However, it can be confusing because you're trying to pull together multiple concepts at one time. This is basically stoichiometry just with some solution calculations just tacked on to it. And I'll show you how to work that. I think it'll help you out, so maybe you'll be able to get it when it comes time for the test. How many milliliters of 0.750 molar phosphoric acid, H3PO4, are required to react with 250 milliliters of 0.150 molar barium hydroxide if the products are barium phosphate and water? Okay, anytime you have a problem like this, the first thing you need to do is set up a balanced equation. So let's go ahead and start with our two reactants. Okay, when I'm doing my barium phosphate, make sure that you balance your charges. If you look here, you can see you've got 3 hydrogens attached to this phosphate. So if you don't remember from your polyatomic ions, then you can look and see how many hydrogens you have and realize that phosphate must be a -3. And then the barium has 2 hydroxides on it. It is a +2. So the way you balance it, it's going to be Ba3, PO4, 2. And I'm going to get rid of those so they're not confusing. All right, and water. Okay, so now we need to balance the equation, and that's pretty straightforward. It looks like we've got an odd number of hydrogens here, so usually that means that you're going to have to double that. And so that gives us 3 of these, and looks like 6 of these. Looks like everything adds up and looks good, so we'll just go from there. All right, now let's look at what you're given. You're given that you have 250 milliliters of 0.15 molar barium hydroxide. Now, first thing you need to do is convert this to moles, and if you'll recall, 0.150 molar is the same as moles per liter. And so I'm told I have 250 milliliters. Of course, I need that in liters, so I'm just going to say 0.250 liters. Hopefully by now you can do that conversion pretty much without having to write it out. And so if I do the math on that, liters cancel. I'm left with 0.0375 moles of barium hydroxide. Okay, just remember your stoichiometry. You have to have moles to work through this equation. So now I have moles of barium hydroxide. Now I can pretty much find out how many moles of any of these other things that I'd be dealing with. Of course, I'm only really interested in H3PO4, phosphoric acid. So let's go ahead and do the conversion. And so how do I convert between these two? Well, the same way you do for any stoichiometry problem. I'm going to put my 2 H3PO4 on top, my 3 barium hydroxide on the bottom, so I cancel. And so that's going to give me times 2 divided by 3. It's going to give me 0.0250 moles. Okay, so the question was not about moles. The question was how many milliliters of phosphoric acid do I need? So now I know how many moles, but I have to get back to milliliters. Since I'm given a concentration, that's pretty straightforward. I can start with my 0.0250 moles times, all right, remember 0.750 molar is the same as 0.750 moles per liter. But in this case, I want liters on top and moles on the bottom, so I canceled. Okay, so that gives me 0.0333 liters, or you can write that out, 33.3 milliliters. Okay, so hopefully that was helpful to you. If not, please let me know and I can try to help you out some more with it.